So a company offers a starting salary of $65,000 per year. The company gives a 4% raise each year. Write a rule giving the salary of the company for any year. Find the salary during the 5th year of employment and find the sum of wages earned during the first 20 years of employment. So the first parts, A and B, that's nothing new. That's kind of what we had done in geometric sequences. So writing a rule, this 4% raise means that we're getting an increase of 4%. So remember, our percentages have to be 0.04. So an increase means 1 plus 0.04. So that's going to be what my ratio is, the 1 plus 4% more. So that 1 is standing for the $65,000 that I got, plus I'm getting 4% more on top of that. So my rule is going to be A sub n equals my first term, so that starting salary of $65,000 times my ratio, 1.04, to the n minus 1. Find the salary during the 5th year of employment. So that means I want when A sub 5, my 5th term, so 65,000 times 1.04 to the 5 minus 1. So go ahead and type that in your calculator. You want to do 1.04 to the 4th power, multiply by 65,000. Since we're talking about money here, we should get $76,040.81. So make sure we're rounding to that nearest hundredth. All right, so now this last part is saying find the sum of the wages earned during the first 20 years of employment. So we got to think 20 years of employment making $65,000 plus is going to be a lot of money. So this is a sum. This means that we're going to need our first term, which is the 65,000. We're going to need our ratio, which we have as 1.04, and we're going to need our n, which is 20. We're also going to need our sum, our series formula. So S sub 20, because we want the sum of 20 years, equals 65,000 times 1 minus r to the 20th power, all over 1 minus 1.04. So if you go ahead and type that in your calculator. Now at this point, when you type in that 1.04 to the 20th power, you're going to get a whole bunch of decimals. You should keep that in your calculator. So you should try to type this whole thing in by itself, but if you can't, go ahead and multiply by -1 and then add 1 to it, and then multiply by 65,000 and then divide by 1 minus 1.04, making sure to put that in parentheses. So when you do that very carefully, you should end up with $1,935,575.11. So I know I didn't show any work on how I got from here to here, so I will want to see your formula, your equation, and then I will want to see your answer rounded to the correct nearest hundredth. So just be very careful when you're typing this in. Again, those calculators that we have in class, and you should be able to type them in exactly how you see them. So another word problem, the current value of a piece of art is $3,300. Recently, the value of artwork has been decreasing 2.5% annually. If this trend continues, how much value will the piece of art have 6 years from now? So this isn't really a sum problem. This is just a geometric sequence problem where we want to find how much the art is worth after 6 years, so that's telling us that n equals 6. Now the fact that it's decreasing 2.5% annually means that we're losing 2.5%. So we have our original value, 100%, that's what that 1 is, minus 2.5%, so minus 0.025, which means after a year the art is only worth 0.975, so 97.5%. So we've got that R. We've got our A1 is the starting value for the initial value of the artwork, and then we've got our N. So we're going to use our A sub N formula to find the value after 6 years. So we're recognizing that this is not a sum problem. So 3,300, that's my first term, times 0.975. And then my n is now 6 minus 1. So going ahead and typing that into our calculator, we should make sure we're getting a value that's less than what we started. So the answer of $2,907.62 should totally make sense because it's less money than what it was initially worth.